I'm about to show you a ninja shortcut to find the derivative here faster than the product rule. And then in a little bit, I'll tell you the number one shortcut you need to know. So I'm going to take the natural log of both sides here, giving me this expression, and knowing your properties of logarithms on the right-hand side here, we can break that up into a sum of three separate logarithms, right? Now, what's cool about this is I can use a method called implicit differentiation, like I use in the video above. So now what I do is, because on the left-hand side, after taking the derivative with respect to x of both sides of the equation, that derivative for natural log of y is going to be 1 over y, like you normally take a derivative, but then you bring this dy over dx term here. And then on the right-hand side, since we only have x's, we take the derivative using the chain rule like we normally do for natural logs, giving you this expression. And so what I can do now is I want to solve for dy over dx. So by multiplying both sides by y, you get this expression here. And if I told you on an exam that you should have an answer all in terms of x, let's do a bit of work here to get the final answer. Before I do, that number one shortcut you need to know is anytime you see a derivative on a test, don't just use a memorized method. Always look to see if you can save time with the quicker shortcut like we did in this video. So moving on, because we know that y is x plus 1 times x plus 2 times x plus 3, I put it into the equation here, and now all you got to do is just simplify terms, right? We're going to go ahead and multiply things through. And by the way, here's a quiz question for you. Do we have a domain restriction here, since we had these denominators with x plus 1, x plus 2, and so forth? Tell me in the comments below and think about it for a second. Okay, so when you have an answer like this, you can feel free to simplify this on your own and see what you come up with. But the answer is no. There's no domain restriction, because even though implicit differentiation as a method here made it look like we can't divide by 0, the true solution is that because the derivative is a polynomial,